All right, hello. So I decided to switch it up a bit and use this channel for just some Python related topics or just honestly pretty much anything that I feel like doing. So I thought I would give a talk on decorators in Python because I think it's a really useful thing to kind of understand. And if you're coming from like a data science background and you start to work with like some web frameworks like Dash or Flask or Django, you'll see this design pattern a lot, and it looks like a very different syntax. It's very different than anything you really encounter in Python, and it can be very confusing at first. And I think it's a pretty good thing to just know and have kind of in your back pocket if you ever want to use it. So this is kind of like a primer on decorators, what they are, how to use them appropriately, and some interesting things that you could do. So start with a definition. So I got this right off of Google, but decorators are design pattern in Python. So this should say pattern. Let me just change that real quick. Design pattern in Python that allows a user to add new functionality to an existing object without modifying its structure. So really what this looks like is like kind of performing something around a function or setting something on an object. And it's just a really nice like syntactic way of doing that. And again, it can look very foreign if you've never encountered it before, but it's once we break it down, it won't be that bad. It can be a little bit confusing at first. But usually it's interesting that they say an existing object because usually you'll see it done around functions, but it's not limited to functions. So Python, every function is an object, but not every object is a function. And essentially, a function is just like an object with a signature that's callable, and and has some logic within the body as well that executes. So you can decorate a function, but you can also decorate like a class or even like a module. So we'll get into that later. We'll just start with sort of like what the standard use is. So we'll start with an example. Here I have this function loop through, which takes a list as its argument. And then for every element in the list, I'm just going to print the element. And so here I just define a list of none, like 10 none objects, and then I pass it into this loop through function. I call it, we see that it works fine. So suppose that I want to do the above. I don't really want to print it, but I want to iterate through it, but I want to see how long it takes depending on the size of the list. So you could imagine like basically what we have to do is like we do down here, we set up this loop through function where we take a keyword argument. And so this will assume some level of knowledge about like keyword arguments and arguments in Python. So if you don't really know how those work, you should probably do a little bit of like self-research before this. But this function that we're setting up, the purpose is to take a number like again we defined it as size here in the function signature, but size equals to 1000, and set up a list of that size. We can see that's what we do here, and then essentially time how long it takes to iterate over every element in the list. And so for every element in the list, we're just going to pass, and so this perf counter is a method that takes like the time in I believe seconds as of now, in like float seconds, and it's way more accurate than using like a dt.now method. This thing returns you like, this is the most accurate timing you can get. So if you want to do some sort of like data science related project where you're actually timing stuff, well, first of all, I think there's a module called like time it anyways, so that's what we're kind of like recreating here. But you should always stick to perf counter. This is like the best method I know. So essentially what we do is we set up this list of the size that we took as the argument in the function signature. And we get the time now. We loop through every element in the list. We don't really do anything. And then we just take the time after the function minus our original time as a total time. And then we print, the function ran in that total time. So let's go ahead and just run this. And we can see, and again, so I have already ran this before, but we can see that the loop through with 1,000 runs in 1.68 times 10 to the negative 5 seconds, which is really, quick, obviously. But if you noticed, we actually, the time that was sitting there before for the same amount, for the same size list is different now than the size, uh, or for the time that we get running the function again. So this is just part, a problem with your computer in general. Like in these methods, it's not going to be completely accurate. It'll be very close. But a better way of doing this is to do this as a repeated process over and over and over again. And so what the decorator will allow us to do is kind of get rid of this logic that wraps around here, right? So the loop through, we really just want to be able to do this. And so maybe getting a little bit like off topic, maybe didn't set this up so well, but we're just this allows us to remove a lot of duplicated logic, and we'll see that in a second. So we kind of want to be able to keep, like, we want to time any function. We don't want to have to go into the function's body and write this line every single time. That would just be ridiculous, right? We want a way to time any function that we've already set up. So, and particularly, we want to do this, like for the example that I gave, we want to be able to do this like multiple times. So first, let's go with the idea of just creating a wrapper or creating a decorator to kind of get rid of this logic and move it into something that goes around the actual function call. And so this is what that would look like. So we set up this function called timeIt, and it takes a function as its argument. We've named it function. Again, this doesn't have to be a function. It could be any object, but for our purposes, it will be a function. And then on the inside, we define this function called wrapper that has this signature that's just pretty ambiguous. So this signature just allows us to get away with like pretty much any argument and keyword argument. So any signature that a function would define by itself, we're able to take with this syntax, because this just is like, this is one of the beautiful things about Python, is that this just means any arguments and keyword arguments we define, we take them in. So it doesn't matter what the original function signature looks like, we can just handle that with the syntax. And we can see what this is doing is that it takes, it does the same logic that we had up here, but what we see is that it actually gets the time now, runs this function with the arguments and keyword arguments that were passed to wrapper, stores the result of the function, takes the total time by getting the perf counter minus the original time that we had, prints that total time, and here we make a reference to the function name, and then we return the result that we stored up here inside this inner function wrapper. And then the timeIt function itself returns this wrapper function that's on the inside. And so I'll get back to this in a second, but now we can use this syntax where we just say at timeIt, and we do the new loop through, which is essentially this loop through, but without this logic for the timing. And when we run this, and then we run new loop through, what we see is that it actually executes this logic that we see up here. So it's not in the main body of the function, but we're able to see that we had, again, a reference to the name here. The new loop through ran in, and then 2.4 times 10 to the negative 5 seconds. And so here we're just doing it, showing that we get a difference in times between calculating the sum of the first in numbers by using a brute force method versus the first in formula. And we could see that the first in formula is times to the negative second, or times 10 to the negative 6, where this is on the order of 10 to the negative 5. So we see that this is much faster. So it's just kind of like reiterating the fact that our timeIt function is working correctly, because this should be a much cheaper operation than going through the entire list and summing everything. So if you followed so far, and sorry for, I feel like I'm talking quite fast or maybe moving a little bit fast, but Now I'm gonna kind of try to explain what's going on up here. So adding the at time at syntax is actually equivalent to the below. So we have this function, my function that we define here. It just does nothing. It just passes. And if we add that at time at syntax, it's actually what it's doing is it's taking time at, passing the my function into time it, and then setting my function to time it of my function essentially. And so let's try to follow this. So if we go up, we see that time it does take a function as its argument. So this makes sense, right? And what happens is that we get returned this inner wrapper function. So now my function actually is this wrapper function. And again, because we have this star args and star star quark syntax, we actually get to make reference. We actually like it doesn't matter what my function signature looks like. When we call my function with its signature, we can handle that because we just make reference to the arguments and keyword arguments here. So what we're doing essentially is we're getting this inner wrapper function, which has a reference to the original my function because it was passed into the time it. And actually, to be very technical, when this runs originally, and this line runs originally, this my function, which would be my fug in this example, this function here actually is a reference to my function, which gets saved in a dictionary. I think it's called like locals on this wrapper function, which again is an object. So it has an attribute called locals. And one of those locals is a reference to the original my function. So now every time we refer to wrapper, it has a reference to the original my function that we defined, at the, that we passed into this time it up here. So this is always going to refer to that original function that we had. And again, we're just passing in the arguments and keyword arguments that we get for, like, it looks like we're essentially just like calling my function with like some arguments and keyword arguments. And really that's the wrapper with the arguments and keyword arguments. And we're passing those arguments and keyword arguments into function. So my function, you're going to write out the call to my function as you normally would. And then we just get to take the arguments and keyword arguments, pass them in, get the result, and then do something around that. So this is like the simplest case of what a decorator looks like. So kind of going back to the previous example, we saw that there was kind of a change in time when we loop through things. So again, I may have done this kind of out of order, but you want to, oftentimes you're going to want to take like an average over, you're going to want to do this like loop through time it method, but you're going to want to do this a lot of times. So what it would be really nice is if we had something like this, where we had an actual keyword argument that we could pass in to the time it function, where we could say like iters equals to 10,000. So we actually want to be able to run my function, but run it 10,000 times and time it every time, and then basically take the average result of the run times. So if we look at the expressions above and how we had defined this originally, because again, like the way that this syntax works, we actually have to resolve this method first. So whatever this method returns would then have to take the my function as an argument. So this itself has to return a function that can then take my function. So this looks a little bit weird, but if you go back and you try to, I'll post this notebook on GitHub, but if you go back and look at this, it starts to make some sense. So we'll actually have to resolve this, and this line right here actually has to return a function that we can pass my function into, which would set it to this, for this syntax to work at least, right? So this means we get to some really, what looks pretty complex, but if you follow what I've said so far, it does start to make some sense. So here, this is how we would add a keyword argument. So we have this outer function time it, iters equals to 10,000. And then we basically do the same stuff that we had before, because what happens is that this result we return this inner function in the timeIt function, which is like our original decorator that we had. But now what we're doing is that we have a reference to this iters, and you can see that inside of our wrapper function, we do the total time equals to 0. We start at 0 for I in range iters. So we just go through all the iterations that we want. We get the time and we add it on. And then I didn't take the average here, so you can do something with the average, but I did the total time for that many iterations. So again, this would just be dividing the total time by the number of iterations to get the average. But essentially what you're doing is you're taking that, this is kind of our this whole method here is our original decorator. And then we're just returning this original decorator, but we have an additional layer where we can get this reference to the keyword argument. And then again, this is another function. So the result of this is this inner function that we get, which then takes the function. So this actually is the result of this is the inner function. And then that's the like sort of our original decorator. But now we have a reference to the iters keyword again inside of the body of the wrapper function. So this can be a lot to absorb, so you may want to go back and like rewatch, but this is how you would go about that. And so let's just go ahead and these shouldn't run because they're just examples. So we'll go ahead and execute, and then we can run at timeIt with the iters equal to 15,000 and put it on the my function. And we see that we get the result we expect. So 15,000 iterations ran in 0.0033 seconds. And then again, we'll do another example and it works fine. So the problem with this, one of the issues if you set it up like this, if you actually do it yourself, is that you have to actually resolve the method call. So it'd be really nice to have something like this where we don't have, if we didn't want to pass in our keyword argument, we didn't have to actually close off the function like this, or actually call the function timeIt like this, because this looks just a little bit wonky. But we can't do that with the way we set it up. There is a way to resolve this, and I'm just not going to go through it right now because it's not really worth it. There's a better way to do this. So let me go. This is a little bit out of order. So, so this is sort of, okay, well, I set this up pretty bad, but we'll get back to that in a second. There's a better way to resolve this, and that actually makes use of a built-in module in the standard library. So what about decorators on class instance methods? So this is something that's just like pretty particular, but it comes into play in an example that I'll give in a second as well. So what we have here is we have this class my class, and we just have this attribute is important, which is a Boolean, and we set it as default equal to true. And then we have this reduce repeated class logic. So you want to do something every time that a method is called in the class, and we do this by just setting a decorator on these classes instead of doing them each time in the actual body of the function. So the problem is that in an instance method, you have a reference to the self, to the object that this class is actually an instance of, or sorry, not class, the method is actually an instance of, which is usually denoted as self, but you can name it anything you want. But this is the first argument on an instance method, and Python will automatically pass the my class instance to this method as this first argument. So what happens is that if you want to make a decorator on an instance method, all you really need to do, you stay with the same syntax, except you just add this, you kind of hijack the self keyword. So what we're doing up here in this reduce repeated class logic is we're making a decorator that every time we call the function, we set this is important attribute to the opposite of itself. So we're saying self.isImportant equals to not self.isImportant. And then again, we're just hijacking the self keyword argument, and you can imagine that now this wrapper kind of takes the place of this do something important, right? Or this do another important thing similar to above. Terrible naming conventions, but it's just an example. So again, uh, we're just hijacking the self keyword argument and naming it explicitly, and then Python just handles like passing in the instance. So this is kind of how you get away with doing with creating a decorator on a class instance method. And so we'll see that this works in a second. So we create an instance of my class, we initialize it. My class is important. Dot is important is true, as we expect, because we haven't done anything yet. And then we run the do something important, and we print out the attribute again. We see it's false, and then we do again another important thing similar to above, and we print out the is important, and it's true this time. So it's working as expected. Okay, now here's the decorator module, and which is really handy. So this is a module in the standard library, and so again, some of the naming conventions are funny, but it's just the decorator module, and then we have this decorator function. So we're actually using a decorator to help us write decorators in a cleaner way. And this will help us with our keyword argument stuff that was up here. This will resolve this problem of us having to actually call the function on the decorator if we had like some keyword argument defined here. This will take care of that. So this is a really, really useful thing to use. And so you should try to do practice this. But essentially what you do now is, if we look at the example above, all we do is we slap this at decorator. So now Python, this is going to help us with creating this decorator. We say reduce repeated class logic 2, which takes a function. It always takes the function as the first argument, the function that we want to decorate. And then it takes, here in our method, it's just essentially taking the function. It's kind of removing this line, the need for this outer wrapper, and it's just passing this function into this actual method here. So now we have the same signature as before, but we just have the function referenced initially. And so here, all we do is we do self.isImportant equals not self.isImportant, and then we return the result of the function. So again, we could just, if we wanted to do something after the result, we just save the result of the function, do something after it, and then return the result. But we'll see that this works exactly the same as the above. We slap on these decorators with the at reduce repeated class logic 2, and then we see that it's changing the actual is important attribute. So as we had mentioned at the start, there's decorators are not just restricted to functions. They can be used on pretty much any object, and this classes are objects. So the below is a pretty complex example, but if we look at the above, right, let's say that we had 20 methods on this class, which is a little bit overkill, but it's just for example, and we wanted every single one of them to have this reduce repeated class logic decorator. Well, at that point, we're not even really reducing the class logic, because we have to slap the decorator on every instance method, so you're going to see it 20 times anyways. So what we can do is we can create a decorator on the class to actually decorate all of the methods on the class with that particular decorator. So this is where things get pretty spicy. I'll go through this example, but essentially, so the issue is that so we don't get to use this pretty decorator module here, because the decorator module is sort of this decorator function restricts you to actually having a function as the first argument. It won't actually let you use a class. So it'll check this first argument, and then it looks for a signature attribute or something, I believe. And if it doesn't have that, it's not going to let you do it. And classes don't have a signature, so you can't actually use this decorator here. It'll blow things up for you. So what we have to do is we kind of have to brute force our own thing. What happens is that we don't get to use the decorator to define this decorator on the class, but we can keep this our syntax for the actual decorator that we want to put on the class instance methods, or the class instance methods that we want to decorate. So that's why you don't see like a decorator method out here, even though this decorate methods will act as a decorator. But we do make reference to this reduce repeated class logic 2, which does make use of this decorator. So you get to use some of the features, but you don't get to do it all the way because the decorator module just wants to restrict you to decorating functions. So how do we do this? So again, thinking about the syntax above, all this is doing is this is going to execute a function and then set my class equals to decorate methods, this resolved function, and then the like passing in this my class into the result of this, what this function returns. So we have this decorate methods function up here, which takes a decorator, which will be a function in this case, and then an exclude list. And here what we do is you can see again that we define this inner function, and the decorate methods returns that inner function. So that's again, we're again referring back to the syntax originally. This result itself will be a function that then takes my class as the argument in it. Okay, and you can see that here we've referenced CLS, which is like sort of the syntax that you use for referring to a class in Python, instead of a function which we had before, which was a reference to func. Or really, these on the inside would be a reference to the like arguments and keyword arguments, but here it's just actually a reference to the class, and we'll see what this is doing. So let's walk through this. So just another little note about Python, just a slight tangent. If you have a keyword argument that you define in a function signature, and you want that keyword argument to be a mutable object, i.e. a list, or e.g. a list, you should not do something like this, because what happens is that this list gets initialized and stored in the locals variable for this decorate methods. And since a list is a mutable object, if you start to do things where you refer to the default list that you set up here and like sort of like maybe append items to that list over time, you're going to append items to this original list that you set up. So if you want a fresh list every single time that you refer to this function, same with any mutable object, you should always refrain from having mutable objects in your function signature for keyword arguments, and you should do something like this. So what we do is we do none. Again, this is a little tangent, but we set the exclude list equals to none, and then here we basically say, okay, set the exclude list to an empty list inside of the function, so this initializes it every time we call the function instead of just the one time when we set the function up originally. And then if the exclude list is none, otherwise just use the exclude list that they pass. So just again, a little aside, but you should always do this with mutable objects if you have them as keyword arguments in the function signature. So here, what happens is we have this decorate methods, which is going to take our my class, right? So again, this outer method will resolve and turn this inner decorate methods, which will then take the class, right? That as a argument and then return the class. So we're setting my class, let me just write it out. So I'm reiterating it a lot because it looks weird. So this is really what's happening is equals to, and then we'll just do this. So this is what's happening. And again, that's why this CLS is here, because then we pass in my class here. So what we do is we go over every attribute in the class's dictionary. So every object has a _ dict, a dunder dict method. This is referred to as dunder, the double underscores. A dunder dict method that has the name of the attribute and then the corresponding like actual attribute. And so what we're doing here is we're saying if we're going to get the attribute on the class, so we make reference to our class object and the attribute name with getAttr. So that gives us the actual attribute. And if that attribute is callable, i.e. it's a function, and we don't have the double underscore, so there's a bunch of dunder methods that are defined on objects that we just don't really want to mess with, like classes, like the dunder init, dunder equals, dunder str. So all these methods we don't really want to touch and decorate them. So we're just going to ignore, for our sake, the dunder methods here. So if that dunder pattern is not in the attribute name and the attribute is not in our exclude list that we passed here, because we may want to not decorate some methods on the class, and it may be easier to just set up a list that we exclude instead of, saying include all of these ones and write out every single one. It may be easier just, okay, we'll just exclude these two methods. So it just depends on your use case. You can say include list or exclude list, just depends on what you want to do. But the idea is basically, if it's a callable function on the class and doesn't have this pattern and it's not in our exclude list, here I printed the attribute, but I'm going to remove this quickly. What we're doing is we're setting that attribute on the class. We're setting that attribute here on the class to the decorator that we passed in here, which was a function. And we're basically, so this is again just getting the attribute on the class and then decorating it. So essentially what this is doing is it's walking through every method in the class, determining if we want to decorate it, and then decorating it. And this can be used with any function. So here I'm going to execute it. And here you see that we make reference to this reduce repeated class logic 2, which we defined up here. We say add decorate methods, reduce repeated class logic 2, exclude list equals to exclude. And so I've included this exclude, and now we don't have to decorate any of these methods explicitly. And we run this, and I'm just gonna delete this really quick. And so what should happen is that when we make a reference to this do something important to do another thing similar to above, the is important should go from true, it should start at true. When we call this method, it should go to false. When we call this method, it should return to true. And then when we call exclude, it should just stay at true because exclude is in our exclude list and we didn't decorate it with our reduce repeated class logic method. So that's what we'll go ahead and do. That's what this line does. And we see that it works as expected. So again, I'm gonna post this on my GitHub and make a link to it. It's, I maybe went out of order and talked a little bit fast. But this is something that can come in handy, and just kind of knowing what's going on can be really useful. I actually have used this actual decorating a class at work before, and it's very handy, and it's a slick way of getting away with like reducing a lot of your code. It can kind of really clean up your code base. Again, it takes some getting used to, but once you get used to it, you can just start to write your own pretty quickly. And it doesn't become, the logic it gets easier over time. So you'll get used to it over time. You just have to practice it a bit. And, getting away with something like this is really cool because we can do, 30 methods that we decorate with the same decorator. And we just have to make a reference to it one time. So anyways, that's sort of a primer on decorators. Again, I'm going to post the link on GitHub. I'd appreciate if you like the video. I know that I have very little viewers and subscribers, but trying to maybe grow the channel a bit. And just appreciate it. If you like it, give it a thumbs up. If not, whatever. But hopefully you found something useful. So yeah.